Support vector machines, SVM, is a powerful and widely used machine learning algorithm that has its roots in the field of statistics and optimization. Its historical development can be traced back to the 1960s, but it gained popularity in the 1990s and remains relevant in modern machine learning applications. This summary will cover the origins and key milestones in the development of support vector machines, focusing on the work of pioneers such as Vladimir Vapnik and the mathematical concepts that underpin this influential algorithm. The concept of SVM can be traced back to the 1960s when statisticians and mathematicians started exploring the idea of finding the optimal hyperplane to separate data points of different classes. However, it was not until the late 1980s and early 1990s that the SVM framework as we know it today started taking shape. 1. Perceptrons and the origin of linear separability. The idea of finding a hyperplane to separate data points of different classes can be traced back to the work of Frank Rosenblatt in the late 1950s, who developed the concept of perceptrons. Perceptrons were the early attempts at building binary classifiers using linear separation of data points. However, their limitations became evident when they failed to classify non-linearly separable data. 2. Vapnik and Chervonenkis, VC dimension. In the 1960s, mathematicians Vladimir Vapnik and Alexei Chervonenkis introduced the concept of VC. Vapnik-Chervonenkis dimension, which provided a way to measure the capacity or complexity of a hypothesis space, such as the set of all possible hyperplanes. The VC dimension allowed them to quantify the capacity of a classifier to fit random noise in the data, which was a fundamental step towards understanding the generalization ability of machine learning models. 3. The maximal margin classifier. In 1964, Eugene Dinkin proposed the idea of constructing classifiers based on the maximal margin, which was a clear departure from the perceptron model. The maximal margin classifier aimed to find the hyperplane that maximized the margin between the closest data points of different classes. However, computational limitations at the time made the practical implementation of this idea challenging. 4. Support vector machines. The breakthrough came in the early 1990s when Vladimir Vapnik and his colleagues developed the support vector machine (SVM) algorithm. In 1992, Bernard Boser, Isabelle Guyon, and Vladimir Vapnik introduced SVM as a novel approach to binary classification. SVM extended the idea of the maximal margin classifier and introduced the concept of support vectors, which were the data points lying closest to the separating hyperplane. These support vectors played a crucial role in the construction of the decision boundary and the margin. 5. The kernel trick and nonlinear separability. One of the key innovations that made SVM more versatile and powerful was the introduction of the kernel trick by Bernard Boser, Karina Cortez, and Vladimir Vapnik in 1992. The kernel trick allowed SVM to handle non-linearly separable data by implicitly mapping the input data into a higher dimensional space where linear separation becomes possible. This made SVM suitable for a wide range of complex classification tasks. 6. Sequential Minimal Optimization, SMO. As SVM gained popularity, John Platt introduced the Sequential Minimal Optimization, SMO, algorithm in 1998. SMO provided an efficient way to solve the quadratic programming problem involved in training SVMs. This greatly improved the computational efficiency of SVM and enabled its application to larger datasets. 7. Extensions and applications. Over the years, SVM has been extended and adapted for various tasks, such as multiclass classification, regression, and novelty detection. Additionally, SVM has found applications in diverse fields, including computer vision, natural language processing, bioinformatics, and finance. Its ability to handle high-dimensional data, generalization performance, and solid theoretical foundations have contributed to its popularity. In conclusion, support vector machines, SVM, has its origins in the work of mathematicians and statisticians in the 1960s, with significant contributions by Vladimir Vapnik and his colleagues in the 1990s. The concept of finding the maximal margin classifier, combined with the introduction of support vectors and the kernel trick, has made SVM a powerful and versatile machine learning algorithm. Its practical implementation was further improved by the development of efficient optimization algorithms like Sequential Minimal Optimization, SMO. Today, SVM remains a widely used tool for classification, regression, and other machine learning tasks, with applications across various domains.